I can draw my topology, right? In time the people are joining. 105 slash slash 8 slash 8. That's good. All done, right? Okay. I think so. Let's wait for 1 minute more. Then we'll start the session. Okay, right. So, guys, what we have discussed yesterday, we have covered the, you know, the how to configure the MAC address manually, right? We have seen the switch, how the switch learn the MAC address, different ways that switch can learn the MAC address. Either you can go in the dynamic way or either you can go in the static way. The default behavior is a dynamic one, right? And so we have a multiple the scenario we have seen that. So take example, the ARP you can go with the dynamic and MAC we can go with the dynamic. ARP you can go learn the static and you can learn the dynamic. You can learn the ARP dynamic, but the MAC is static, and you can learn the ARP static and MAC is static. So you have a multiple ways, and after the doing the practical, we found that the dynamic is the default behavior, okay, and static is also a good solution. But how many is static you can put in, right? It's not possible to put the 100 plus static, right? So and this two one is not a feasible solution, because in this two one normally what happen, you have a unknown unicast flooding. It's a very important question in the interview. What is unknown unicast flooding? So whenever the frame received by the switch, right, and switch is not able to determine the destination map in the map table, he got confused. What should I do with the packet now? So he normally broadcasts the packet to the every interface, right? He just flood the packet to the every interface. That mechanism is called as a unknown unicast flooding. Remember one thing, in the unknown unicast flooding, right, the packet is unicast. In the broadcasting, the packet itself is a broadcast. Again, I'm repeating, in the unknown unicast flooding, the packet itself is a unicast, and in the broadcasting, the packet itself is a broadcast. Then after that, we have seen that how to change the MAC aging time, which is by default 300 seconds. It is not recommendation to change it, but yeah, in some scenario, you can change this time, but again, you have to have a proper answer for that on why you are changing the time. Because if you're changing the time, it might impact to the other services as well, right? Because your ARP table is a 4 hours, right? And your MAC table is a 300 seconds. So if there is a mismatch is happening, another service also get impacted. Because in a Windows, it's in a Cisco router, we have a 4 hours of the time. But take example, if you have a multi-vendor scenario where you have a different boxes, right? So maybe Juniper, HP, Palo, and Apple, the Windows. In that case, you will get some problem, right? So avoid changing the time until unless you don't have a proper thing. Yeah, definitely when you go for the high level of the training, right, like a CCT and the enterprise CCI, then you will get to know that more information, like why do we need to change the timer and why do we not need to change the timer. Then after we have also seen that for each VLAN, right, we have a separate MAC address table. Okay, and for each VLAN, you can change the MAC aging time as well. So for example, we have spoke about for the VLAN number 10, this is the MAC table. For the VLAN number 20, we have a MAC table. And for the VLAN number 10, I see that, okay, the MAC aging time is what? 400 seconds. I can call this guy as your MAC aging time is a 500 seconds. And of course, the global is what? The global is a 300 seconds. So whatever the VLANs, that's not a part of the VLAN 10 and 20 are part of the global aging time, right? Then after that, we have seen that why do we need to configure the VLAN, right? So VLAN is basically what? It's a logical domain, right? So it's a logical LAN area network. So if you explain what is VLAN, it's a logical LAN area network. So logically, what we are doing that we are creating the LAN area network. So we are dividing the big broadcast domain into the small broadcast domain. You may have a question, hey, Law, I can do this way as well as. So right now you can see that I'm using the same subnet. You can see the 1.1 IP address, 1.2 IP address, 1.3 IP address, 104, 105, 106, 107, 108, 109. You can also do one thing. What you can do that, without creating the VLAN, you can also segregate this thing. How? I can call this guy as a 1.0.0.0/8. I can call this guy as a 2.0.0.0/8. I can call this guy as a 3.0.0/8. Right? I can do that, but try to understand if you're gonna segregate, or if you're gonna break the broadcast domain like this way, defining the different subnet. In that case, also we can achieve the same thing, right? This guy cannot communicate with this person, and this guy cannot communicate with this person. I can achieve it, but the problem is that what you have to take the multiple subnet and try to understand if you have a multiple subnet in your LAN network, then what happened? You will have a multiple routing information on the router side. So eventually this switch is going to connect with the router, right? So on the router side, you have a three different types of route: 1.0, 2.0, and 3.0. And each route consume the some amount of memory and CPU. Okay, so that's why it's not recommendation to define a different subnet. So what we are doing that, instead of putting the different subnet, what I can do that in the same subnet, you can see that right now, they are the same subnet: 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. They are the part of the same subnet. In the same subnet, what I can do that, I will logically, right? I will logically define a logical network. And that logical network is known as a VLAN. And each area, each of logical broadcast domain, right, has some identifier. Each of logical broadcast domain has some identifier, and that identifier is called as a VLAN ID. So VLAN ID is basically a number, a integer number, right? VLAN ID is what? It's basically an integer number. You can define any number. You can define up to the 12 bit. 12 bit in the sense of what? You can go up to the 4094. This is the range you can define it. So maybe you have a question, hey, Law, the 12 bit is a 4096. So try to understand, starting with a 0 and end with a 4095. So this 2-1 is reserved. You cannot use it. This 2-1 is reserved. You cannot use it. You can up to use the 4094. So we have ranges start over what? 1 to 4094. So from this range, you can define any VLAN number. I can define the 10, I can define the 20, I can define the 40, anything. It's up to me. So I will define what, right? Again, this logical broadcast domain, I can see that. This is the one broadcast domain I have, right? This is the another logical broadcast domain we have. Okay, and this is the another logical broadcast domain I have now. So I have a three different logical broadcast domain over here. The most interesting thing is what over here. If you see, they all are part of the same subnet, and each one has a identified. So I can call this guy, your identified is what? I can call this guy. This is going to represent as a VLAN number 10. This is going to represent as a VLAN number 20. And this is going to represent as a VLAN number 30. So this is the identifier that I'm going to define to this logical broadcast domain. And now what? Now we can start the configuration. So if you guys remember that yesterday we did the configuration of the VLAN, how to configure it. So let me open my switch. the first you need to click on the CLI, that's stand for the command line interface. And by default, wait, the switch interface is up, router interface is done. So you don't need to put the no shutdown command on the switch side. You only need to put the no shutdown command on the router side. So what you can do that simply, I have logged in the user mode. Then you need to go in the privilege mode by putting the enable command. You can also use the tab keyboard to auto complete the command. And then you need to go in the config terminal mode to just configure the VLAN. If you want to define the host name, you can define the host name as a switch 1. And now I can say that, hey, let's do the VLAN over there. So I said the VLAN number 10. Perfect. I don't want to define the name. If you don't want to define the name, what happened? The names comes with the VLAN number. If you don't define the name, the names comes with the VLAN number. So I'm just not defining the name. VLAN 20, exit, VLAN number 30, exit. That's all. Creating the VLAN, guys, please pay attention. Creating the VLAN, it doesn't mean that. Creating the VLAN, it doesn't mean that you have segregated the ports. Still, they are the part of the VLAN number 1. If you do so VLAN brief, if you put this command, you can see that VLAN number 1, all the ports are the part of the VLAN number 1. Again, I'm repeating, creating the 3 different VLAN, it doesn't mean that you are segregating the broadcast domain. It only means that you just created the VLAN, nothing else. Still right now, they are the part of the same broadcast domain. So let me show you that. I'll just configure the IP address on this all PC right now. 1.1.1.1. 1.1.2. 1.1.3. 1.1.4. Someone mic is on, guys. Please be on mute. If you have a question, you can ask me. Otherwise, be on mute. 1.1.6. Right. 1.7. 1.8. So this is the manual configuration of the IP address that I'm doing right now. It's static. If you have a DSCP, then you can use the DSCP keyword over there. Just log in over there. So right now I don't have a DSCP. It will take the APIPA and 19/8. That's all. So I just create the IP addresses. If you see one thing, the interesting part is what? I have a 3 different VLAN item, VLAN 10, 20, and 30. And by default, VLAN 1 is present. Okay. And all the ports of the part of the VLAN number 1. Even right now, if I'm going to make any broadcast traffic from the PC1, even if I'm going to make any broadcast traffic from the PC1, it will send to the everybody. The reason is that because all the ports are the part of the VLAN number 1. Okay, so let me show you this one. I'm going to make a broadcast traffic from the PC1. You can see that just sending the PC2, packet comes to the switch and switch will broadcast this packet. Right? Understood? So creating the VLAN, it doesn't mean that you have segregated the broadcast domain. You need to assign the ports. You need to assign the ports. So let's do one thing. Let's assign the port, whatever the ports we have. So you can see that I have a PC1 is 0/1. You can see that. Okay. PC2 is a 0/2 and PC3 is a 0/3. So I can use my notepad. Okay. As the interface 0/1. Right. Switch port. Mode access. Interface 0/2. Not access, sorry. Switch port access VLAN number 10. Switch port access VLAN number 20. Sorry, not still 10. Because 0/1, 2, and 3 is a part of the VLAN number 10. And 0/3. So these 3 interfaces are the part of the VLAN number 10. And now copy and paste it. That's done. So now if you're going to see exit and do so VLAN brief, same command. Previously, all my interface 0/1, 2, and 3 was a part of the which VLAN? It's a part of the VLAN number 1. Once I allocate this interface into the particular VLAN, now this information will be away from the VLAN number 1 and will be there in the VLAN number 10 now. It's not there in the 1 and 2 and 3 in the VLAN number 1. Hold on, guys. Someone send me a WhatsApp message to me. Okay. So we have VLAN 10, 1, 0, 1, 2, 3, and same way you can assign for the VLAN 20. So you have, if you see, we have a 0/4. The PC4 is 0/4. PC5 is a 0/5. And PC6 is a 0/6. So what you can do that, you can also put the same command. I can say that 0/4 should be the part of what? 20. Zero slash five.
Zero,
Sorry, 0/4.
0/4.
4,
You can write. Okay.
And this should be also 20 now. And 0/5 will be 6, will be 20. Same way, I'm just going to copy and paste this command on the switch one. And here we go. Done. So now previously this interface was a part of what? 0/4, 5, 6 is a part of the VLAN number 1. Once I put this command, write this interface to be the part of the 20. Now this will be there in the VLAN number 20. Do so VLAN brief. Now the 4, 5, 6 is not there in the VLAN number 1. Same way I can do the 7, 8, and 9. So instead of putting the all this 3 statement, what I can do that I do have a range keyword. Cisco allow you the beautiful command. You have a range keyword. What is the meaning of range? You can combine the 0/7, 0/8, and 0/9 in a single line. So instead of putting the 3 lines of configuration, right, you just put the 1 line of configuration. So it doesn't mean that it's gonna save your resources of the route switches. It's just gonna save your time. Okay, so you can put the interface range, right? Which interface we have? 0/7. 2, I can put the 9 over there. I think it will keep the space in between. And then I can say that switch port access VLAN number 30. That's it. So in a single sort, right? In a single sort, what happened? I assign the 3 interface into the VLAN. So do so VLAN brief now. You can see that 0/7, 8, 9, 10 is a part of the VLAN 30. And that's how the VLAN is gonna work, guys. Hold on, this interface in the Ember state right now.
Hello.
Yeah. Go ahead. Listening you.
Hello.
Yeah, listening. Go ahead. I'm listening.
Sir, my
Yeah, I'm listening.
from green color. Suppose, sir, green color. Yes, I can tell you, sir. Ping from green color to red color. Is it possible, sir? Ping
Orange to pink. What do you mean by orange to pink? Pink
means suppose, sir, orange color IP1 is, sir, what? 1 PC3. 1
okay.
And another is from red color PC9. 1.1.1.9/8.
I'm coming to the
ping
point, sir.
it.
I'm coming to the point. Hold on. I'm
No,
coming.
I am just.
I understand
Okay,
you,
very
sir.
nice.
Hold on.
Okay,
So
okay.
right now you can see that although we have IP addresses, now try to understand, guys. If I'm going to generate any broadcast traffic, take example right now. If I'm going to generate any broadcast traffic from the PC3, right? The ARP is a broadcast packet, right? Your ARP request is a broadcast packet. So if I'm going to generate from the PC3 to PC2, have a look. This is my ARP packet. That is a broadcast packet. Can you see that FFF? Right? When this packet comes to the switch, right? Switch will receive the packet on which interface? it will receive the packet on the 0/3 interface. And 0/3 is a part of which VLAN? VLAN number 10. It means that we are receiving the traffic on which VLAN? We are receiving the traffic on the VLAN number 10 because 0/3 is a part of the VLAN number 10, 0/2 is the part of the VLAN number 10, and 0/1 is a part of the VLAN number 10. In a VLAN number 20, what information we have? We have a 0/4, we have 0/5, and we have 0/6. In a VLAN number 30, what information we have? We have a 0/7, 0/8, and 0/9. So if I'm receiving a packet on this particular interface, on which VLAN? VLAN number 10, I'm only gonna make a broadcast within the VLAN. I'm only gonna send the packet to the 2 and 1. I cannot send the packet beyond this domain. So have a look. When I receive the packet, I'm only sending the packet to the same VLAN. I'm not sending it to this guys. And that's the meaning of the VLAN. Still, the beauty part is what? They are the part of the same subnet. I logically, with the help of VLAN, what happened? I logically segregate the broadcast domain, which is by default not possible on the switch side, but with the help of VLAN, it is possible. Now, yesterday also I mentioned this point as well, right? That sort of asked the question, can I communicate between the PC3 to the PC9? No, you cannot communicate. Between the VLANs, there is no communication is happening by default. Within the VLAN,
sir.
you can provide the communication. Between the VLAN, there is no communication. So if I'm going to ping from here to here, take example. If I'm going to send the traffic from the PC3, have a look. I can ping, right, 1.1.1.2, which is my same VLAN, PC3 to PC2. I can ping 1.1 even, right? But I cannot send the traffic to the 1.9 because now it's a different VLAN. VLAN 10 to the VLAN 30, it's not going to communicate. So I cannot send the traffic from the PC3 to PC9 because they are the part of a different VLAN. That's the beauty of the VLAN. Guys, any question do you have till now?
Sir, I think, can I tell you, sir, I think, sir, maybe we need, sir, router या inter-VLAN command. I think, sir.
But then we'll discuss those things. Don't worry about that. Okay, so this
No,
is
I'm just asking, sir.
Yeah, you are right. So this is how you can configure the VLAN on the switch side. Now have a look one more thing. If you see on the switch, go on the switch, and if you put the command so interface 0/1 switch port. So sum up the verification command. Okay, you can see that this interface 0/1, which is the switch port enable. The meaning of that of this line is saying that this is the layer 2 interface. This is the meaning of the switch port is means that what? It's a layer 2 interface. Now, if you see one other thing is that this interface is the part of which VLAN? VLAN number 10. Apart from these things, leave it right now. You will get to know that days by. At the end of the topic of the VLAN, you have all the information. So right now, the most important information is what? Switch port is enabled. That's the meaning of layer 2 interface. And the access mode is the VLAN number 10. Now, somebody has asked the question yesterday, how many interface you can allocate into the VLAN? For example, we have a 0/0 interface. How many VLAN I can allocate to this interface? So basically, you can only allocate the one data VLAN, right? So for example, if I'm going to allocate the VLAN number 10, that's my data VLAN. I cannot allocate the data VLAN 20. Data VLAN means what? The traffic that you are sending, that's called the data traffic. A traffic could be data traffic. A traffic could be the video traffic. A traffic could be the voice traffic, right? A traffic could be anything. So a data traffic, I can assign the VLAN number 10. But if I'm going to assign the VLAN number 20, then what happened? This information will be removed from there. It will be override the information. I can only allocate the one VLAN to that particular interface. Yeah. At the same time, you can allocate the, for example, I can allocate the voice VLAN for the different VLAN as well. I can allocate the voice VLAN as a maybe 100. So data VLAN 20 and the voice VLAN as a 100. I can do this way, right? But if I talk about, because we are learning the right now data networking, not the voice, not the even the storage. So let's focus on the data. You can only allocate the one VLAN on the single interface, not the other VLAN. I think so. Biru has asked this question yesterday. Am I right, Biru? Are you there today or not? I have no idea. So this is how you can see that information. Now let's take example. What happened if you have this kind of topology? Okay, great. So let me change this topology now. I go with the, so do you have any question in this topology? If you have, you can ask this. What is the VLAN 99? What is VLAN 99? Nothing is VLAN 9. VLAN 99 is a normal 99 VLAN. It's normal 99 VLAN.
Sir, I have one question, sir.
Yes.
When you configure VLAN, suppose sir switch port status is enable. In case sir, in a real company, suppose in the enable, if this is disabled, then what type of command we can configure, sir?
So in that case, what you can do that simply, for example, interface 0/01. So normally, sorry, interface 0/ what interface we have? Sorry, interface fast in 0/1. Take example, you have a no switch port over there, right? The meaning
Yes,
of this
sir.
command is meaning of what? It's become the layer 3 interface. So normally what happened? Your interface is a part of the switchboard. That's a default behavior, right? That's a default behavior. Your interface is a switchboard. It means that it's a layer 2 interface. But sometimes what happened? In a production, you have a no switchboard configure. So if you have a no switchboard configure, it means that the interface is not a layer 2. Now it becomes the layer 3 interface. So simply what you can do that, you just put the command switchboard. So once you can put the command switchboard, then it will become the layer 2 again. And then you can configure the switchboard.
Okay, clear.
VLAN number 10. Understood?
Okay, clear. Okay, sir, clear, sir.
So we can assign only one VLAN of the each type data voice VLAN to the port time, but we can assign the more than one type of VLAN to the port at yeah, one voice, one data. I haven't checked the video personally, I'll tell you, but not more than the one data, more than one. Yes, right. I haven't checked for the video. I just talk about the we have a video traffic as well. That's my perception. But normally I have seen that, like whatever the data. And so what is the management VLAN? Management VLAN is nothing when you have a multiple users are the part of the management and you want to dedicately management traffic. So normally what happens in a network, you have a different types of traffic. You have a data traffic, right? You have a voice traffic. You have a what we call a video traffic, right? Another type of traffic is called as a management traffic. Management traffic means what? Your normally SSH or telnet traffic, and you want to segregate this traffic, right, from the other one. Then what you can do that? Either I can put that in the different subnet, right? Either I can put in the different subnet, or either what you can do that you can simply assign the different VLAN. I can say the VLAN number 200 is the part of the management. So whatever the user, right, are sitting in the management side, they are the part of the management VLAN. So I'm unable to unmute yourself, ask the question because you muted just, I know I haven't muted anyone.
Hello, sir.
Yes, I can hear you. I haven't muted anyone. Yeah, go ahead.
Please repeat this.
Which one? The management VLAN?
Yes, yes.
Yeah. I asked to unmute. I haven't muted Beauty. Even I cannot unmute you. So what I'm saying that, so take example, you have a different users. For example, you have a data users, you have voice user, you have a video user, right? And you have this user, what we call management user. They are trying to access the device through the SSH and telnet, right? So in that case, what you can do that, if you don't gonna segregate, if you take example, if you don't gonna segregate it, then what happens? If something is happening in this data side, it might impact it to the management side as well. For example, if there is an attack is happening in the data side, it impact to the management side as well, right? So if it is going to impact to the management side, then you cannot make access to the different router. So what you can do that you simply segregate this thing by using what? By using the VLAN. That's called as a management VLAN. So I can also assign any VLAN, VLAN number 200, and I will call this VLAN as a management VLAN. Okay, not sure, no problem. Thanks for trying. I'll be my question over there. Is the default VLAN label different or same? Default VLAN native VLAN by default it's same. But if you want, you can change it. Any other questions, anyone?
Yes, we have, hello.
Yeah.
Sir, I have configured switches.
Mm-hmm.
First, suppose management VLAN is 500.
Mm-hmm.
Then a data VLAN or voice VLAN and a printer VLAN. These are,
Different.
yes,
Okay.
that's it.
That's your question.
Yes.
So what you want me to expect this answer? I didn't get understand your question.
Management VLAN or access VLAN, data VLAN too.
Oh, both are same, right?
Yes.
So there is no, so if there is any attack is happening in the data VLAN, it might impact the management VLAN as well.
Yes, yes. Okay, sir.
Okay, so let's move to the forward, guys. I'll go with the new topology now. So this is how about you can provide the communication on the single switch. Again, I'm repeating, this is how the communication is happening on the single switch. Okay, guys, now please be on the, let me go with the. So this is all the communication is happening on the single switch. Let's take example. Now we have a different topology. Take example, I have a switch 1. Okay. And switch 2. So previously, what are the whatever the lab we did on the single switch, right? Now we have two different switch now. We have a switch 1 and we have a switch 2. So I have a few users. Take example, the user is PC number, guys, please pay attention. PC number 1. I have a PC number 2. I have a PC number 3. Right? And I'll make this guy all this in the single again, copy and paste. So on the switch 2 also we have the same users. Okay, so now let's take example. I'll just provide the connectivity with the PC1, PC2, PC3, PC4, PC5, and PC6. Now we have a between switch 1 to switch 2, I have a link, right? Of course, we need to provide any connectivity, right? The wire media. And we have a PC number 1, PC number 2, PC number 3, PC number 4, PC number 5, PC number 6, right? Then we have an interface we had. I call this guy as a 0/1. I call this guy as a 0/2. I call this guy as 0/3. Same way, this interface is called as 0/4, and this interface is 0/4, right? 0/ again, okay, not a big deal. 0/1, 0/2, 0/3. Now, as I mentioned that by default, right? By default, all the ports are part of VLAN number 1. And by default, VLAN number 1 is present on switch. Right? Now, IP address of this interface, assume that it's a IP, I can call it the word IP 1.1.1.1, MAC will be A, and the VLAN number will be, take example, I call it a 10. This guy, PC2 we have now. This guy's a 1 or 2, the MAC B, and the VLAN number 20. And this guy, I'm not going to allocate to the any VLAN. So normally, if I'm not going to allocate to the any VLAN, it's part of the VLAN number 1. Same way we have this guy should be 1 or 4, this guy should be MAC D, and this guy's a VLAN number 10. This guy will be 1 or 5, this guy will be MAC E, and the VLAN number 20, and this guy will be 1.6, MAC E, and the VLAN number 1 again. Okay, so that's how the things are configured. So let me tell you on the when you connect the two switches, does it affect the port speed? What do you mean by when you connect the two switches? Does it affect the port speed? It's up to the you, right? What port speed you are gonna putting over there between the two switches. Normally, you are putting the fast Ethernet, which is the like 100 Mbps and 200 Mbps, even the 1 gig as well, even if you're putting the gig Ethernet cable. So it doesn't impact anything. It's up to you. So
Sir.
now, yes.
If sir speed is difference for two switch, is it effect for the network, sir?
Of course, it's gonna impact the network. Take example, normal take example. You are driving your car, okay?
Yes, sir. Yes, sir.
You are driving the car on a bad road, right? This is the bad road. Like normally on the hometown, what happened? A rural area, right? A rural area has a very bad roads, right? You cannot drive your car on the speed. So normally you can drive the car on the 4 km/h, right? But
Okay,
when you
okay,
go to
sir.
the highway, right? When you go to the highway, this is the highway, the 4-line highway we have. On a highway, what happened? You can drive your car on the 100 km/h, right? Same example is going to happen. If you're going to send the traffic on the lower link, it's go well slow. If you're going to send the traffic on the higher link, it's going to really high. Yeah, if you want a very understanding knowledge about this thing, like how the traffic is moving on the interface side and the router side, then you have to wait for the quality of service. That comes in the C side. You have a quality of service in the CCNP as well, but it's just a theory part, not the practical one. Okay, right. So requesting everyone is kindly stick to the question that law is discussing at the moment. All the other questions we should wait for the end of the class. Thanks. So what I'm trying to say, the switch 1, switch 2 we have, and these are the IP addresses. You can see that over there, and these are the IP addresses. Now pay attention over there, guys. What I'm trying to say, let me remove this guy. I'll just put it over there. Okay. Now, if you look for the switch MAC, right? If you look for the switch information, what you can see that on a 0/1, the port number, you can see that the port we have, right? And the VLAN. And the MAC. Try to understand, we just put a port and VLAN, that's enough one. So I can say that port is a 0/1 is the part of the VLAN number 10, right? Port 0/2, we have a part of the VLAN number 20. And port 0/3, guys, it's very important topic. Please pay attention. 0/1 and 0/4, the part of the VLAN number 1 again. Okay. Now, how about the MAC address table of the switch 2? If you see the switch 2 MAC address table, right? You have a same information, only the change the port number. So we have a 0/1 again, 0/2 part of the VLAN number 20, 0/3 part of the VLAN number 1, right? And 0/4 is the part of the same one. Now, tell me one thing. If I'm going to send the traffic from the PC1, right? If I'm going to send the traffic from the PC, this is the how that you have created the VLAN table right now. So either you can see the VLAN table, that's you put in the command, so VLAN brief. So normally you can see this information, right? So VLAN brief. Either you can understand the MAC table. So normally in the MAC table, you have a MAC information, but leave it, just understands the VLAN table, right? Not the MAC table right now. Otherwise you will get confused. Understand the concept. So if I'm going to send the traffic, right, from the PC1, not the traffic, I just want to verify the connectivity between the PC1 to the PC4. If you see, they all are the part of the same VLAN right now. What happened in that case? If I'm going to make a ping, 1.1.1.4, what happened in that case? Normally the PC1 is going to generate, I'm just going to draw the packet over here. So normally the PC A is going to generate the packet where we have a source MAC will be A, distance MAC. I have no idea, right? Source IP will be 1.1 and distance IP will be 1.4. This packet will be go on the hold, right? And after the 2 seconds that we have discussed in the last few classes, that's a timeout of the ICMP. If I'm not get the reply within the 2 seconds, the packet will be dropped eventually, right? Then what happened before the dropping the packet, I will create the ARP request packet, right? So ARP request will be how? Let me draw over here. I don't have space. This is the ARP request packet that PC1 is going to generate. So we have a source MAC and distance MAC will be FFF. Now what 0x0806. Then we have a source MAC A, distance MAC will be what? 00 source IP 1.1 destination IP 1.4. This is the Ethernet header and this is the ARP header. Now, when this packet comes from this PC1, right, the switch one will receive this packet on this particular interface. This interface is the part of which VLAN number 10. Okay, perfect. I received the packet on this particular interface. I will learn the MAC entry as well, right? I will learn the MAC entry on the 0/1 port number. I will learn the MAC entry is A, part of the VLAN number 10. Perfect. That's our first step. Learn the source MAC address. What destination is saying that? Broadcast. Tell me one thing. Can I make a broadcast right now? Can I send the packet to the any other interface? No, we cannot.
No.
The reason is that we don't have any other ports of the part of the VLAN number 10.
Yes, sir.
We don't have any other ports in the VLAN number 10. So in that case, normally what happened? Your packet will be dropped at this point. The reason is very simple in front of you guys. I don't have any other ports in the VLAN number 10. So it means that I cannot send the traffic from here to here. If you see, I already have a link in between, but I cannot send the traffic. It means that if you have a VLAN number 10 and VLAN number 10 on the two different switch, if you have the same VLAN, still you are not able to communicate. Look for the previous example that we did. In a previous example, we had a 3 VLAN user, right? But the beauty of that topology is what? They all are connected to the single switch. But now the connectivity is happening between the two switches. And that's how we are not able to communicate. But take example, what happened if I'm going to make a communication between the PC3 to the PC6? Let's take example, if I'm going to generate the packet in that case, what happened? So if I'm going to generate the packet, so assume that this is my ICMP request packet that PC3 is going to send for the PC6. So source MAC will be C, distance MAC. I really have no idea. Source IP 1.3, distance IP 1.6. This packet go on the hold, right? Then after that, I will create the ARP request packet. ARP request packet will be source MAC will be C, distance MAC will be FFF, right? And then we have a C000 source IP 1.3 and distance IP 1.6. Guys, what happened in that case? PC3 will send the traffic to the on this particular interface. Switch will receive it. They will learn this entry. Okay, 0/3. I'm going to learn the MAC C, VLAN number 1. And now I will look for the destination MAC. The destination MAC is a broadcast. Man, I can make a broadcast on this particular interface. When the switch 2 will receive this broadcast traffic, on which port? On 0/4, they will learn it. Okay, on a 0/4, I will learn the MAC address, which MAC address, C MAC address for the VLAN number 1. That's a MAC table. And now I will make a broadcasting on which interface? 0/3. I do have a communication. The reason is that these two ports are the same broadcast domain right now. These two ports are in the same broadcast domain right now. And that's why we are able to communicate it. And that's why we are not able to communicate it because of this VLAN number 10, 0/1 is the part of the VLAN number 10, and 0/1 is the 0/4 is the part of the VLAN number 1. Different VLAN, no communication. Guys, have a look at this picture right now in front of you. I'll just do the cross sign because no communication is happening. I'll just put the tick sign because communication is happening same VLAN. Have a look at the picture in your mind. Take it 2 minutes, okay, and understand the scenario. Because this scenario is very, very important, right, for the further classes. And not for the further class, even for the interview as well. All done? You can please explain again last bit. The last bit I said that this interface 0/3 and 0/4 is a part of the same VLAN, VLAN number 1, and that's why the PC3 can communicate with the PC6, because even on the switch to the 0/4 and 0/3 is a part of the same VLAN. But over here, when the traffic was sending from the VLAN number 10, this interface is the part of the VLAN number 10, but this interface that is providing the connectivity between the two switches is a part of the different VLAN, VLAN number 1 and VLAN number 10. No communication is going to happen. PC3 switch 1 is the VLAN number 1, same VLAN, that's why. You understood, Nasir? PC1, it's not the same here. PC1 is a different. PC1 is a part of the VLAN number 10. Can you see that? 0/1, but this interface is the part of the VLAN number 1. It's not going to communicate, right? It's a different VLAN.
But the PC3 has a only what VLAN is another PC3.
PC3 can communicate, right? Because if you see the PC, when the PC3 sends the packet, it's received on the 0/3 port number. And if you see the VLAN table, 0/3 and 0/4 are the part of the same VLAN, right?
Okay.
So I can send the traffic to the switch 2. Switch 2 will receive the traffic on this interface 0/4, right? 0/4 and 0/3 is a part of the same VLAN, and they can send the traffic easily to the PC6.
So on switch to the PC number 4, that has a VLAN number 1, right? Okay. And
PC6 is a part of the VLAN number. Okay, I have mentioned that. Can you see that? 0/4, 0/3 and 0/4 port number.
Maybe if
03.
we highlight the VLAN 1 in separate colors on both sides, that might make it easier for us to understand, I guess.
Can you see that now?
Actually, 03 and 04 on both sides. Actually, 04,
Mm-hmm.
03 and
03.
04. Yeah, that's
It's
right.
part of the
Yeah.
same VLAN. Can you see that?
Okay. But you cannot configure a VLAN on the link, isn't it? On the 04.
I haven't configured it. It's a part of the by default. It's a VLAN number 1. I haven't configured it.
But the switch is a different switch, right?
Sorry?
The switch is different switch. Without the inter VLAN, how is this possible?
I'm not talking about the inter VLAN right now. Just understand the concept I'm talking about. See, what I'm trying to say in this lab, if you have a VLAN number 10, right? If you have a VLAN number 10 on the switch 1, and if you have a VLAN number 10 on the switch 2 as well, right? There's no communication is happening. Right? Whereas if you have a VLAN number 1 on the switch 1, right? And VLAN number 1 on the switch 2, the communication is happening.
Okay, I see. So I think the confusion is because when we started discussing VLAN, we were just discussing it initially from the single switch perspective.
We spoke
believe
about the single switch perspective, right? And now we are talking. That's
right. And I believe what you are trying to explain here is, and as I understand, after you highlighted, is that even though we have two different switches here, and both switches are interconnected, and as long as the ports on both switches are part of the same VLAN, they can communicate with each other without need of any extra device or router.
Right.
Just because they are part of the same VLAN.
Because this interface is a part of the same VLAN.
Okay.
That interface that between the switch 1 and switch 2. But if you see, this interface 0/1 is a part of which VLAN?
VLAN number 10.
So tell me one thing. If I'm receiving the packet of the VLAN number 10, this broadcast packet, where I need to forward? In the VLAN number 10 only, right?
That's right. Yeah, correct. Yeah.
Yes,
So do we have any VLAN number 10 and any other port we have on the switch 1? Except the 0/1?
No.
So what should I do? I will drop the packet.
Correct. Yeah.
Now you got it?
Yeah, got it. Yeah.
That's why
But
we are not
on
able to communicate between this guy to this guy. Reason is that because I don't have a ports. But
the
at the same
question
time,
is, mhm,
at the same time, when the PC3 is sending this packet, right? This
okay,
is the packet. You said the source MAC is a C, destination MAC is
okay,
FF. So when this guy will send the packet on the 0/3 port number, what is the destination MAC? FFM. So when I see I can broadcast this packet on which interface? 0/4, right? Because I'm receiving the packet on the 0/3, I can make a broadcast in the 0/4, right? I can send the easily traffic.
oh,
When the switch 2 will receive it, on which interface? 0/4, on which VLAN? He can make a
VLAN number
broadcast on
1.
which interface? 0/3. He's doing the broadcasting on this interface.
It's basically what I understand. I mean, what understood. Because let's say start from the switch 1. On PC3, switch 1 is configured as a VLAN number 1, right?
Mhm.
Okay.
Mhm.
And when we try to send the traffic to the switch 2
Mhm.
on PC number 4, that is also a part of the VLAN 1. So they both are on the same VLAN. That means the communication will be happen. Is that
Right.
right?
Yeah, because this interface is also part of the same VLAN. And this interface is
Okay.
also part of the same. That's why communication is
Oh.
happening.
Okay, so if we talk about the PC1, right, at the switch 1, that is a part of the VLAN number 10. Okay.
Okay.
If it tries to communicate with for
It's not going to
example,
communicate because this interface is the part of a different VLAN. That's the issue.
So
I
you need to
see.
assign the 04 also VLAN number 10. Then you can communicate to others.
Yeah, that's a good answer, right? So now if I take
Mhm.
example, if I'm going to make this interface, take example. Now if I'm going to make this interface as a part of the VLAN number 10, right? Guys, please pay attention. That I'm saying always, don't put your
Sure.
question. Listen to me carefully. VLAN number 10. And again, I'm going to remove this interface from the 1 and make this guy the 10 again. Then what happened? Now, this guy is able to communicate with this person. But again, now this person cannot communicate with this person.
Okay, but that's fine. That's understood. But the question is, okay, so now you have configured the VLAN number 10 on which interface of the switch 1?
0/4, can you see that?
I see.
Yes, sir. Yes, sir. Understood, sir.
And again, 0/4 is the
Baba,
VLAN number 10. Now we can communicate with the VLAN number 10 to the VLAN number 10. I don't have any issue because this
I
part
mean,
is the part of the same VLAN number 10. This part is the part of the same VLAN number 10.
I mean, I never knew that you are able to configure the VLAN on the link between the two switches.
Right?
And
Simple.
you are allowed to do that, right? You
Right?
can do that.
I am the admin. I can do that.
Okay, that's fine. Okay. Before I thought maybe you can only configure the VLANs, let's say on the users 1
Oh,
to 3.
okay. I think Nasir, that is a good question. Even I'm a little curious now, because these links, and if I understand correctly, are the link for between the switches. What they call, again, I don't want to jump ahead.
Yeah.
but
So
for the
don't jump ahead right now.
communication
Just hold on. Let me explain this thing. Then you can put the question. Don't jump ahead right now.
Okay.
Okay, let me complete this thing. Now, guys, please pay attention. I have a few things. See, just focus on the class right now. Whatever the questions you have, just write the questions, all the question in your notebook. And please pay attention in the class, because the reason is that I can explain you in all the different way that you may encounter the interview questions, right? So let's have a look now. Well, I'm going to remove this guy as well. So I'll just put the default behavior VLAN number 1.
No, I have question about that topic, what we were discussing right now about that port 4 being in VLAN 10. A quick question about the same topic.
Okay.
What I was trying to understand is, even though that port 4 on both sides is the link for between the switches, can it also be configured in VLAN, let's say 1 or 10 for that matter? That's what I think. That's what I was trying to
told you
understand.
that your one interface can be a member of the one VLAN, one data VLAN. So if I already make a part of the VLAN number 1, I cannot allocate the VLAN number 10 for this interface, right?
No, because based on what you said, if 04 and let's say 04 on both sides is part of VLAN 1, correct? So how will the data from port 1, which is part of VLAN 10, will travel across port 04 on both sides, because then 04 is a part of different VLAN? Or am I misunderstanding that?
Yeah, they cannot travel it. I cannot send the traffic from here to here now. The problem is that it's a
No, I
part.
understand that. So that's what I'm trying to understand.
Okay, so
in
this is a question,
scenario-
right? What will be the solution for this one? You are looking for that. Coming to the
No, I'm just trying to understand. So if I'm not looking for solution, I'm just trying to understand. So if the port 04 on both sides, which is also a inter switch link, right, is made if their port 04 are configured for a different VLAN than, let's say, PC1 and PC2. So if they are sending traffic,
1 minute,
those
PC1 and PC2. It's a PC1 and PC4 we have. PC2 is there.
I'm sorry, PC1 and 2 on this side and PC4 and 5 on the other side. They won't be able to communicate to each other over this port 04, which is the only link between the two switches.
They won't communicate.
Okay, that's all. I just wanted to make sure that I understood that correctly. That's all.
Right. You understood
Thank
the correct. You understood the correct. So basically, what's happening? So 0/4 and 0/4. Right now, you can see that that's why I created the database table over here. It's a VLAN table, guys. Okay. So this is the part of the which VLAN? VLAN number 1. So only the VLAN number 1 person can communicate each other. No other person. VLAN 10 cannot communicate with VLAN 10. VLAN 20 cannot communicate with VLAN number 20. Because the guy we have over here, he's saying that I can only carry the VLAN number 1 traffic, not other than. Got it?
Yes.
Great.
Sure.
Yes, sir.
Yeah, that's fine. That's another thing.
Okay, great.
I mean, as an admin, so you are able to permit or deny the traffic basically, which one you want to,
Right.
isn't it? Basically, like if you want to allow the traffic for 1, 2, or 3, you can do that.
Yeah,
But
I'm the admin. I can do that anything.
Okay, so one more thing for this is the last question. If you do not, deny any traffic or restrict any traffic on, if you want to communicate all of them, 1, 2, 3, 4, 5, 6 on the power switch. So if you do not put any block on the links between the switches, so then it will be just like you can do that as an
We can do that definitely. I'm coming to that scenario.
that will be through the access port, right?
That will be through the trunk port, not the access port. These are the access port.
Sorry, yeah, trunk port. Sorry, apologies. Yeah, between two switches. Yes, that's right. Yeah.
I'm coming to the point. So now let's take example. Forget the trunk right now. We haven't discussed the trunk. Okay, forget it. Tell me another solution. I know you guys are a good knowledge have. Tell me the other solution if you don't have a trunk. Take example, some switches doesn't support the trunking as well. Take example, my switches doesn't support the trunking. What should I do now?
Yes, sir.
So take
We
example.
need to communicate with individual, like for each and every VLAN, we need to give the links.
Exactly, perfect answer. So if you don't have a trunking, then what I can do that I'll make another link over there. I'll make another link over there. And I'll allocate this link as a 0/6. Now I'll allocate this link as 0/7. So this link is going to carry the VLAN number 1 traffic dedicatedly. This link is going to carry the VLAN number 10 traffic dedicatedly. And this traffic is going to carry the VLAN number 20 traffic dedicatedly. Now all the user can communicate. VLAN number 1 will send the traffic. VLAN number 10 will send the traffic through this particular link to this guy. Same way, the VLAN number 20 will send the traffic through this particular link to this guy. And when the VLAN number 1 wants to communicate with the VLAN number 1, they will send the traffic to this particular link. And that's how we can achieve the solution, right? Without doing trunking. Without doing trunking, we can achieve this solution.
Hello,
Sorry?
sir.
Yeah,
Can you repeat again? I can't understood, sir.
okay. So what I'm saying that if you don't have a trunk, what you can do that you can individually create a link between the switch 1 and switch 2, right? I have added the one link 0/6. for the VLAN number 10. I have added the 0/4, which is VLAN number 1.
Yes,
I have
sir.
added another link 0/7 for the VLAN number 20. So I can send the traffic, right? For the VLAN number 10, I can send the traffic for the
Yes, sir.
0/6. For the VLAN number 20, I can send the traffic for the 0/7. And for the VLAN number 1, I can send the traffic for the VLAN number 1. That's an individual one, dedicated traffic for each particular port. But what is the problem?
Okay, sir.
What is the problem of this one? The problem of this one is what? Guys, please be on. Yeah, go ahead. So the problem is that, right? How many links you're gonna add? How many? Tell me one thing. Take example, if you have a 100 VLAN. Take example, if you have 100 VLAN in your network, is it possible that I can add the 100 VLAN? No. Simple
No,
example.
sir.
There's a laptop over there. On this laptop, not a laptop, forget the laptop right now. Understand the television we have, right? This is the television. Is it possible that I can put the separate cable for the Netflix? I can put the separate cable for the Amazon Prime. I can put the separate cable for the Hotstar. I can put the separate cable for the G5. Is it possible that? No.
No,
It's
sir.
not possible. So normally what happened, you have a single link, right? You have a single link. That single link is going to carry the Netflix, Hotstar, Amazon Prime, and G5. That's how, even if you check your TV right now, the dish TV you have, normally in the single cable, you are receiving all kinds of traffic. Same thing, right? It's not possible that we can put the 100 cables between the switch 1 and switch 2. If you're going to put it, then what happened? First of all, this design is a totally worst design. Okay, this design will be the worst ever design. Second thing is that are totally based of money, right? How many cables you're going to put? If you're going to bring the new cables, you have to put the cost for that one. And again, you don't have that amount of port over here. If you're going to add the multiple cables in that particular port, you are wasting the switch capacity as well. So putting the extra cable for the single VLAN, it's not a worth. That's why we come with the another solution is known as a trunk. So there's another guy who comes in the picture. He said, hey, I'm the guy, my name is a trunk, and I do have an ability to carry all the VLAN traffic. The another guy comes in the picture. He said, hey, don't worry about that. I do have ability. I can carry all the VLAN traffic. It means that through a single link, I can carry all the 12-bit of VLAN 4094. All the VLAN I can carry on the single link. And that link is known as a trunk link. That link is known as a trunk link. So basically, you have two types of link. One is called as a
other one is a trunk.
one is the access port, right? Which is normally connected to the PC, or we can call as the end host, simple language.
The same switch.
Yep, man. And the
So,
another, yes.
So if sir printer is connected to the switch, means printer is the access port, sir.
Yeah, access port, right? End host. It means that single VLAN. Let me write on this
Okay,
as
okay.
well. I'll
Okay,
just
sir.
reduce it because I don't have a space. I'll make it like this. Simple single VLAN. Right? Trunk port means what? Between switches. Between switches or router, even the server as well. It can carry multiple VLAN. Okay, if I understand correctly, the link between the switches that carry all the VLAN traffic back to forth is the trunk. So we don't have to create amazing one. We do. So we have two types of trunk. Hold on, guys. I need to Control X. So we have two types of interface. One is called the trunk port. Another is called the access port. So trunk port we have between the switch 1 to the switch 2, and access port are these my. So we can call as a. Let me write on the first thing. So Control V. So these are my access port. This is my access port. This is my access port, which is a part of the single VLAN. Can you see that? These are the part of the single VLAN. Whereas this guy is my trunk port now. So this is again access port. This is the again access port. This is the again access port. So once, listen to me again carefully, guys. Please pay attention. Once I'm gonna make this interface as a trunk port and say that 0/port is a trunk port and 0/port is a trunk port, then what happened? This information will be disappeared from the VLAN number 1. It's gone. Because now this interface is going to carry all the VLAN traffic from 1 to 4094. I just mentioned that 0 and 4095, you cannot use it, right? And this is now we don't have over here. That's done. So now the question is how I make a trunk. So normally, as I mentioned that you have a trunk in between so take example, you have a router and switch. This link would be the trunk, right? You have a switch and switch. This link will be a trunk, and you have a switch to the server, right? You have a trunk. Even switch to the trunk. The reason is that between the switch and server is a trunk because a server can accept multiple VLAN traffic. That's why we need to make this guy as a trunk. He can accept the VLAN number 10 traffic, VLAN number 20 traffic, VLAN number 30, right? So I need to make this interface as a trunk. So trunk can be between the router to switch, switch to switch, and server to switch. Now, how we can make a trunk? So there is a 2 ways, right? There is a 2 ways to make a trunk. There's a 2 ways to make a trunk. One way is known as a manual. Second way, you can use the dynamic way. So first way is known as a manual way. Manual means what? A network engineer comes in the picture. This network engineer comes in the picture and he will say that, hey, you know one thing, I will create the trunk for you. And second way we have, it's called a dynamic way. When the dynamic comes in the picture, right? When the dynamic comes in the picture, you have a protocol path for that one. And the protocol is known as it's a DTP protocol. The protocol for this guy is known as a DTP protocol, dynamic trunking protocol. So DTP is another person. DTP is another person, a very happy person because this guy is a Cisco proprietary protocol. You can only run on the Cisco devices. So he's a very happy guy. He can say that I can only run on the Cisco devices and I can dynamically make a trunk between the switches. So 2 types of way the trunk. One you can call it the manual and one is called the dynamic. Trunk is what? Trunk is one of the interface that can carry all the VLAN traffic. By default. By default means what? When I use the keyword by default, it means that you can change the behavior. You can change the behavior in the sense of what? You can filter out the VLAN. Again, leave it that part right now. We'll discuss it. But yeah, this is how the default behavior is there. Manual means what? You just need to go on the switch type, on the switch side, under the switch 1. Make it 10. Don't have a space, man. Just please be with me. ./port. I see the switch port because it's my layer 2 interface, right? I see the switch port mode is what? I see the trunk. That's a manual way to define the trunk. Switch to the same time, interface 0/4. I can say that my interface is a trunk interface. Which interface is a trunk interface? My 0/4 is a trunk interface. Now, is it done? Okay, let's take example. It's done now. Let's take example. It's done now. Now, understand the problem again. So after the making a trunk, we have another problem. The problem, I'll let you know, explain you the problem. So take example now. What happened? If you guys remember that, I gave you the example of the duplicate MAC address yesterday, right? Okay, so let's take example. What we have a MACD as well. So we have a MACD over here and MACD over here, same MAC. Okay. Now I will generate the packet from PC1. So normally the PC1 will first generate the ping 1.1.1.4, right? So in that 1.1.4, what happened? The first it will generate the ICMP request packet. I'm not going to draw it. After that, what happened? He will generate the ARP request packet. Okay. So the MAC will be E, and the MAC will be distance will be FFF, and the MAC will be 80/0/000 1.1 and 1.4. Switch, guys, pay attention. Switch forward the frame based on the MAC information, not the IP. Switch forward the frame based on the MAC. Now, we already have a trunk, no issue. So when the switch PC1 is going to send the frame to the 0/1 port number. Okay, this is the access port. That's a part of the VLAN number 10. Now what switch one will be doing? I have a trunk, I can send the traffic. Because this is the broadcast traffic, I can flood this traffic to the 0/4 number. Why I'm going to send the traffic on the 0/4 number? The reason is that it's going to carry all the VLAN traffic, even the VLAN number 10. I'm not going to forward this broadcast packet on this particular interface, not this interface. Reason is that because 0/2 is the part of the VLAN number 20 and 0/3 is the part of the VLAN number 1. So I'm not going to forward the packet on this particular port. Once I forward the packet on the switch 2, what switch 2 will do that? It's going to broadcast, right? It's going to broadcast this packet. Now, it will receive the packet by the VLAN number 10 because I'm receiving the packet on 0/4, or it will receive the VLAN number 20. On which interface should I receive the packet? 0/4, right? 0/4 is a part of the trunk port. So do we have any kind of tagging over there? That switch 2 can identify, this guy can identify, hey, I need to forward this packet to the VLAN number 10. Do you see any kind of like any values over there in this packet? We just have a MAC and IP information. That's all. I don't have any kind of tag over there. That switch 2 can identify, okay, I received the packet on this particular interface. Now what? The switch 2 said, hey, now what? After receiving the packet, where should I put the broadcast? Over here, I received the packet on the 0/1 port number. Can you see that? Why it's not working? What happened? Guys, 1 minute. Okay. Yeah. So the PC1 has sent the packet on the 0/1 port number. 0/1 is the part of the VLAN number 10, right? Now, based on the distance and MAC address, I am broadcasting this packet on the VLAN number 10. This interface is the part of the VLAN number 10 because of the trunk. I'm broadcasting the packet on the 0/4. I received it. What should I do now? Where should I broadcast this packet? That's a problem. So after the making into trunk, the problem is another way. How do I identify in which VLAN should I perform the broadcasting? And that's why tagging comes in the picture. Tagging is what? Tagging is just like a one symbol. Like a normally, if you go to the company, right? Every company has a own identity card. Like Cisco has a own, Juniper has a own, HP has a own, right? Palo has a own. They have own ID card. So if you're wearing the Cisco ID card, you cannot go to the Juniper one. And if you're wearing the Juniper ID card, you cannot go to the Cisco. And if you're wearing the HP ID card, right? If you carry the HP ID card, you cannot move in the Palo Alto. If you have a Checkpoint ID card, you can only go to the Checkpoint. So tagging is what? It's an identification we need to put. What ID I'm going to put it over there? I'm going to put the VLAN ID. And based on this tagging, I can identify. So if I'm going to put the tag over there, take example, hey, this is the VLAN number 10. So when the switch will receive this packet, understand this concept. Now, when the switch 2 will receive this packet on this particular interface 0/4, what this guy said that now I'm a happy person. I can see the tag is the VLAN number 10. I can send the traffic to the VLAN number 10, not to the VLAN number 20. MAC is same. I'm only sending the packet to the VLAN number based on the tagging. So once you make a trunk, right, after the making a trunk, once you call the trunk person, I need to call the another person, and that name is a tagging. So one guy name is a trunk, another guy name is a tagging. And both things you are going to configure on the 0/4 port number. So there is a two ways to define the tagging, right? There is a two ways to define the tagging. Right? One, we have a (80.1q) protocol. So one person name is a 80.1q, another person name is a ISL. The very basic difference is that ISL is a Cisco provided protocol. Sorry. ISL. One is a Cisco provided protocol, one is a IEEE standard protocol. So it means that if you have two different switches, one we have a Cisco and one we have a Juniper, you can go with the one we have a Cisco switch and one we have a Juniper switch. And if you have a link between, and if you're not making a tagging, you have to run the 80.1q protocol. And if you have a Cisco, right, Cisco, then you can go with the ISL. This is the one of the major difference, right? If I talk about the high level of the difference, the high level difference is what? Simple reason is that, right? There is a one courier you have, right? There is a one courier you have, and that courier, the weight of this courier is what? The weight of this courier is of 4 kg. Take example. So if I'm going to use this courier service 80.1q protocol, they will add the extra weight 4 kg. But if I'm going to use the right same courier that has a 4 kg, and if I'm going to use this protocol ISL, right, to make a tagging, then I have to use the 30 kg extra. So if I'm going to use the ISL, it gives the extra overhead. If I'm going to use the ISL, it will give the extra overhead. So normally what ISL is doing, that ISL is adding a 30 byte of extra header. It adding the 30 byte. It's a very enough one extra header. Whereas the 26 byte is a ISL header, right? And 4 byte is a FCS header, frame check sequence. That's for the integrity. Right, total is 30 byte of extra header. I'm using the ISL. But if I'm going to use the 80.1q, I'm just going to add the 4 byte of extra header. That's why I mentioned the 4 kg. This is the normal packet, and I'm adding the 80.1q with the 4 kg. So whatever the packet size we have, I'm just going to add the extra 4 byte of header with the help of 80.1q. Now, which one is a recommendation to do that? Always it is a recommendation to use the 80.1q protocol. Even the Cisco is recommended. Even in the Cisco is recommended to use the 80.1q protocol. Don't use the ISL protocol. If you're going to use the ISL protocol, it will create a issue on the overhead. So now let's summarize it. What we did. We have a switch 1 and we have a switch 2. So if you want to send all the VLAN traffic on this particular link, 0/4 and 0/4, if you want to send all the VLAN traffic on this particular link, you have to make this interface as a trunk port. You have to call the trunk guy. At the same time, you need to perform the tagging. The reason of the tagging is what? So that we switches can identify in which VLAN I should make a broadcast and in which VLAN I should send the traffic. That's a use of tagging. Trunk, you can define the manual, right? And you can define the dynamic as well as. In the dynamic, we have a protocol is known as the DTP protocol. That's a Cisco provided protocol. Manual, you need to manually configure the command. tagging in, we have two options. One, you have a 80.1q protocol, and another is a ISL. So ISL just a proprietary protocol, right? It's not recommendation to use because it's add extra 30 byte of header. 80.1q protocol just a 4 byte of header, and that's an amazing one. Even the 80.1q you can run between the two different vendor. Right, guys. So this is how you can run the two things over there. So the first thing, you need to make a switchboard mode trunk. The first command you have, and after that you need to make a tagging protocol. I need to run the 80.1q. Plus 80.1q tagging protocol, so that I can identify the tag. So now if you see what I can do, that I'll open my VMware. Let me open my, if you have a question, meantime, you can ask me because I need 2 minutes to open my web IOU.
So can you install the web IOU on VMware? Because I thought maybe AVNG you can do on VMware, right?
Yes,
You
sir,
can do the
EVNG.
EVNG, you can do the web, anything you can do that. I personally love the web IOU. That's why I'm doing on the web IOU. You can do on the EVNG too.
But do you need a virtualization as well when you install the?
Where you need a virtualization, right? With the EVNG and web IOU too.
Okay. The only issue I have on my laptop is there is a actually virtualization. Also, I have enabled in BIOS, but still it's not letting me to do it. So I got only option of GNS3.
Yeah, man. GNS3. There are also good things, like you can do the practical on the GNS3 too. Like, yeah, I started my things, the career with the GNS3 only, right? I love GNS3. Even if you see on the routing practical, I'm doing on the GNS3 only. I started by this, like, this one, EVNG, when when I started reading the data center and the service provider, then I started the EVNG. But all my enterprise training and routing switching training, right, I did on the GNS3 only.
I prefer EVNG, but unfortunately it doesn't work. So I don't know.
Sir, then how can we do the practical, sir?
You can do the practical on the EVNG.
Okay, okay. Same command, same thing is we can put,
Yeah,
sir.
same command is nothing different, same command. So I assume there will be additional command for the
Okay,
on
okay.
every link, that is the code of the data. Yes, we do. We have a additional link. So additional command. I'll just put in the command over there. Switch 1, switch 2. I don't know how many users I have made it. Let me check. R3, R4. These are my actually a PC. I think so. I have many PC.
I heard someone asking about lab, and that reminds me, I have a question. Does like what is the minimum in terms of the iOS? And we can discuss this later if it is not the time right now. But what is the version of minimum version that we should be using for the current exam, keeping in mind, or does it not matter?
I'm coming to the point as well. Even you can get this answer on the Cisco website too, right? If you read about but yeah, definitely I'd like to give the answer of this one as well. Hold on.
Okay.
I can do one thing.
Oh, okay.
After the class, I'll send you the docs of that one. Even you can see, like, they have all the information for that one.
Okay. Yeah, no, so I was just, checking somewhere about the
I
labs,
completely
and I just
understand.
didn't want to, spend time and money in something that I don't know about. So
No, not a big deal, man. And I'll definitely help you. Don't worry about that.
thank you.
Oh, shit. Okay, so we have devices in front of you guys. Let me change my putty size first of all. I have a 16, let me make it 19. So let me make it 9 and session default setting, save it. And here we have a save position. Great. So let me take a router 3 console. No, we have. Yes, we have. So according to the router name, I'm just going to configure the IP addresses like R4 will be 1.4, right? R5 will be 1.5, R6 will be 1.6, and R7 will be 1.7. So basically it's a router. I'm just using like a PC. R8 will be 1.8, R9 will be 1.9, R10 will be 1.10, 11 will be 1.11, and last 12. I don't know to whom I saw this lab. This is a very big one. I'm going to use a different VLANs. So let me first configure the IP addresses, then I'll see the VLAN as well. So interface, host name will be R3, interface 80/0 IP address will be. I'll convert this as a PC, so I say the new IP routing. If I'm going to disable the routing on the router, it behave like a PC. Come on, host name will be R4, interface 0/0, IP address will be 101.1.1.4. Okay. See this configuration for my future reference as well. Why we have R6 we have do WR means I'm saving the configuration, right? Do write memory.
So these are the real iOS images you're working with right now, or is this
It's not
simulator
a
or
real,
something
it's
like
a
that?
virtual one,
A virtual one, okay.
but it's feel me like a real one. That's why I'm using the WebIO.
Okay. So this WebIOU is like available online. I mean, I don't know if I asked you.
I can give you the rate of that,
Okay.
but not
Thanks.
now. I will give you in the,
No,
once
no, of course, no rush.
yeah,
No rush.
I'll upload it. Just remind me on the weekend, okay? So I'll upload it, but I need to find it where it is present right now in my drive. But just inform, just remind me on the weekend. 109. So sometimes people get bored with the EVNG, right? You can try the WebIO. But I'll teach you how to use the WebIO because it's a different way to create the lab over here. Right now, all the lab is created on my laptop. But yeah, it's a tricky way to create the lab over here. And it consumes very less CPU and very less CPU, very lightweight. Like if you're gonna take example, if you're gonna use the same lab on the EVNG or GNS3, so take example, I'm just giving the random roughly number. So it will take the 30% CPU on the EVNG on GNS3. But if I'm gonna do the same thing on the WebIO, it's just taking 10%. So on my system right now, I have a 16 gig RAM. And can you see that how many routers we are running right now? Almost 12 routers and 14 devices we are running. I can go with the almost 50 plus devices. It's a very lightweight, the WebIO. Okay, so that's how that are 12 now. Interface we choose /0 IP address we 1.1.12. And now all done. So the user side I'm done. let's gonna create the switch side. So now switch side, what I can do that, I'll simply configure the according to the diagram. I'll just say that switch one. Switch one, I say the interface E0/1. I say the switch port access VLAN number 10. I'll make sure that this guy should be the VLAN number 10. Okay, this guy should be the VLAN number 20, and this is part of the VLAN number 1. Okay, switch one. So interface, I'll just use the range keyword better to use 0/0 to 1 2 3, right? Switch port access VLAN number 10. Interface E0/. If you see, I'm not creating the VLAN. Okay, have a look. I'm not creating the VLAN. So now you are getting more advanced now. I'm not creating the VLAN. So if you're not going to create the VLAN, and if you put the command switch port access VLAN number 10, so what switch will do? First, it look up in the database table. Hey, do I know about the VLAN number 10? Switch say that, hey, maybe I don't know because I'm not able to find the information in the VLAN database table. Let me create the VLAN for you. So if you don't have a VLAN, and if you're assigning the port to the VLAN, switch create the VLAN for you. Now interface range E0/3 to, oh my God, I have a 0/3, then I have to use a comma ETH1/0 because we have a different range, right? ETH1 is starting, it's not a 0, so I have to use the comma over in between. Let's put access VLAN number 20. And I don't need to do anything with the ETH1, man. It's because ETH1 is a part of the VLAN number 1, right? So I'm just allocating the VLAN to the switches. That's all. No and yes. No and yes. And I'll just come back in 1 minute. Okay. Switch one. Enable. Right, and copy and paste. We have VLAN number 10 and 20, right? And even the same thing if you see in the switch 2, right? I'm gonna host name will be switch 2, right? Which interface we are gonna create it. So I will make this guy's a VLAN number 10, this guy's a VLAN number 20, and this guy's a VLAN number 1. So interface we have over there, so switch 2. Someone mic is on, guys. On the switch 2, we have same thing. Okay, interface range E0/1 to the 2, switch port access VLAN number 10, and interface E0/3 to the ETH1/0. That's done, right? Now switch to 0/1 and 2 to the VLAN 10, 0/3 ETH1/0 VLAN 20, and 0 ETH1/1 should be the part of the VLAN number 1. So we don't need to configure this thing. So switch to, yeah, let me check. Do we have a VLAN over there? I must not. Already the VLAN 10 is there. Let me remove it. Maybe like a backward configuration over there, which will get it now. Maybe I did the slab previously. That's why it's there. No, let me get it. So if you see this message was not created shown on the switch 1. The reason was that because it was already there, the VLAN. So when I put this command, it was not showing any message, right? Because this VLAN was already present. Now, if you see, when I put this message, I got this information. Switch port access VLAN number 10. I don't have the VLAN number 10. Can you see that? What he's doing there? Access VLAN 10 does not exist. Let me create it. Same thing. VLAN 20 is not there. Let me create it. So if you don't have a VLAN, switch will create for you. Now, if you see the do so VLAN div, I have a proper ports. And VLAN number 1, which is by default present. The most interesting concept, if you have a look over there, is what? ETH0/0 is a part of which VLAN? VLAN number 1. It means that, understood this concept now. If you go to the router number 3, which is this guy, if I'm gonna send the traffic to this guy locally, I can send it. I don't have any issue. Reason is that because they are the part of the same switch, right? So locally it will switch ping 10104 perfectly. So when the switch 1 will receive the packet on this particular interface 0/1, it will switch the packet to the 0/2. What do I am not switching it? Oh, my bad. Interface is down, man. Can you see that? I haven't not put that no shutdown command over there. Do the same thing on the switch R4 as well. It's up. You can see the ping is working now. Locally. Now let's ping it from here to here. Can I ping it here to here? I cannot. Can I ping from the R3 to R8? I cannot do that. They are still part of the same VLAN, but I cannot send the traffic. Not gonna work. Reason is that because still this interface is the part of the which VLAN? VLAN number 1. But I can send the traffic from here to here, R7 to the R12, because this is the part of the VLAN number 1, this is the part of the VLAN number 1, and this interface both are the part of the VLAN number 1. That's why I can send the traffic from the router 7 to the router 12. Have a look. Do ping. It's gonna go. It's working. So what we have to do that, if you want to send the traffic from this PC, if you want to send the traffic from this PC to this PC, between the two switches, I need to make this interface as a trunk, and we need to enable the tagging protocol. I mentioned that you have 2 ways to make a trunk. The first way is you can manually create the trunk. And once you create the trunk, if you see right now, this interface is the 0/0 is the part of the VLAN number 1. Once I made this interface, right, 0/0 as a part of the trunk, then what happened? This interface will be removed from the VLAN. What I can do that, I'll simply go into the interface, answer the switch port, what mode trunk. Ignore this error message right now. It's just saying that you need to define the encapsulation type. That's meaning that you need to enable the encapsulation protocol. That's my tagging protocol. We have switch port trunk encapsulation .1q and then switch port mode trunk. So the first command, I need to make this encapsulation is what? Tagging is what? .1q protocol. I can use the ISL. ISL is a by default. If you don't configure the tagging protocol, by default, it comes to the ISL. And the second command I did is switch port mode trunk, means make this interface as a trunk. Same thing, just go on the switch 2 as well. On a switch 2, interface is 0/0, switch port trunk encapsulation .1q and switch port mode trunk. So I'm saying that, let me explain you this line. Right? I'm saying that switch port trunk encapsulation .1q switch port mode trunk means what? 80/4, right? On a switch 1 and switch 2, same command will be there on the switch 1 and switch 2. I'll just mention over here. Switch 1 and switch 2. I'm saying that, hey, this interface is a layer 2 interface. This interface is a layer 2 interface. I want to make this interface as a trunk. Okay, but before gonna make a trunk, I need to enable the .1q protocol. That's a 80.1q protocol. I need to perform the tagging of what? 80.1q. A tagging, a synonyms of the tagging you can call as an encapsulation as well, right? Tagging is what? It's an encapsulation. Adding an extra header is known as encapsulation, right? So normally when your packet, right? Normally when your packet comes, for example, source MAC A and destination MAC D, right, from here to here, A and D, then what happened? When this packet comes to the access port, when transferring the packet from the access port to the 0/ port on the trunk port, what trunk port will do that? It will add a tag. The tag will be of VLAN number 10 because this packet is going on the VLAN number 10. And now it will send this packet to home 0/ port. When the 0/ port will receive this frame, what he will do that? He did the encapsulation because adding the header encapsulation. When the 0/ port will remove this packet, what he will do that? He will remove the tag over there. He will remove the tag from there. That's called as a decapsulation. And when he will remove the tag, it will just send the normal packet to whom? This guy. So PC will receive the normal packet. PC does not have any idea that you did the encapsulation in between. So encapsulation will happen on the trunk interface and decapsulation will happen on the trunk interface. Matlab, then the meaning of this one is what? Adding a tag is happening on the trunk interface and removing the tag is happening on the trunk interface. Access port doesn't have any idea of tagging. Access port doesn't have any idea of tagging. Cannot remove this one. I'll just mention that. Trunk interface can add the tag and remove the tag. Access port only receive untagged packet. Trunk port receive tagged packet. So tagging is only going to happen on the trunk port, not the access port. On an access port, you will receive the normal blank packet A and D. So when it receive on the 0/ port, they will perform the encapsulation. When it receive by the 0/ port, switch to, they will perform the decapsulation and send the normal packet to the user. So that's the meaning of this complete command line. Okay, so now if you see, have a look over here. This man topology. If you see, have a look over here, I made this tagging. Now you can see that on the switch one, do show interface. First of all, so the do show VLAN brief, you can see that the 0/0 is not there now. It's not a part of the any VLAN. 0/0 is not a part of the any VLAN now. (0/0) is not a part of the any VLAN. It's not there because this 0/0 is a part of now what? It's part of now the trunk part. So if you put the command do show VLAN, do show interface trunk, right? Have a look. This interface is a trunk, right? Mode is on. Encapsulation that I'm using the tagging protocol. It's a 80.1q. Status is trunking. Native VLAN is what? 1. I'll come to the point of this native VLAN. And each 0/0, this interface is now going to carry all the VLAN traffic. Right now, which VLAN traffic they are carrying? 10, 20, and 1. All the VLAN traffic that I can carry on this particular interface. Same thing, same output you can see on the switch 2 as well. Do show interface trunk. You can see that mode is on. It's protocol trunking, native VLAN. All the VLAN is allowed. This VLAN is active right now. So this interface 0/0, which is a trunk interface, you cannot see in a VLAN. You can see that in the VLAN number 1, we have a 1, 2, and 3. 10, we have a 0/1 and 2. 20, we have a 0/3 and 1, 0. But 0/0 is not there because this 0/0 is now a part of the trunk. So if it is a part of the trunk, it will not a part of the any VLAN. It's part of the every VLAN. Now, one more point, I just mentioned that over here, because this VLAN, right? This VLAN is a part of the VLAN number 1. Can you see that? if this is the part of the VLAN number 1, it's called as a native VLAN. Native VLAN is what? The native VLAN is what? It's part of the default VLAN. That's a native VLAN. And for the native VLAN, there is no tagging. It means that, take example, there was a X and Y, that's a MAC address. So if this router 7 is going to generate the packet X and Y, this packet comes to the switch. What switch will do that? It's a trunk interface, right? He will not do the tagging. He will just send the normal packet X and Y. He will receive it X and Y, and he will send the X1, Y to this guy. So there is no tagging is happening when the packet is coming from the native VLAN. When the packet is coming from the native VLAN, there will be no tagging. But when the packet is coming from, take example, MAC is A and MAC is B, right? When the packet is coming from A to B, when this packet is received by the 0/1, which is my access port. Access port does not perform any tagging. When it receives on the trunk port 0/0, what he will do that? He will add the tagging A plus B at the VLAN number 10. When it comes to the switch to this interface, what he will do that? It receive like this one, A and B and VLAN number 10. He add the tag, that's called the encapsulation, right? What switch 2 will do that? He will receive the tag, that's called the decapsulation. He will remove the tag and he will just send the packet to the normal to this guy, A and B. So you can see that this packet is for the native VLAN. Native VLAN does not perform the tagging. So whenever trunk receive the packet and it is a part of the native VLAN, because you can see that in this output as well. Native VLAN 1, and this packet is coming from the VLAN number 1, and it's a native VLAN. So I will not do any kind of tagging for this one. So for the native VLAN, there is no tagging. For the normal VLAN, there should be a tagging. So let me write on this part. Also over here. Let me take a different color. Native VLAN does not do that. You can change the native VLAN if you want. So for example, right now, VLAN number 1, which is default behavior. VLAN number 1 is a default VLAN and native VLAN. That's a default behavior, right? That's a default one. So for VLAN number 1, there will be no tag. Normally, switch send untagged packet for native VLAN, which is the VLAN number 1, right? So take example, if I'm going to make this guy as a VLAN number 10 as a native VLAN, I do have ability, I can make this guy as a VLAN number 10 as a native VLAN. So if I'm going to make this guy as a VLAN number 10 as a native VLAN, then there will be no tag. Now you may have a question, how many native VLAN you can make? You can make it only one. Either you can make a 1, either you can make a 10, either you can make a 20, either you can make a 100, anything. What is the use of changing the native VLAN? Nisha, that you will get to know that in, I can say that in VLAN hopping, then when I'm going to teach you the security, and you will get to know that. But right now, that's a basic info about the native VLAN. What is the use case? Then you will see in the VLAN security when I'm going to discuss about those things. So if you want to see this one example, let me explain you over here. So if I'm going to change, take example, if I'm going to say the native VLAN is 10 now, then what happened? There will be no tagging for the native 10 now. It's normal packet. It's a normal packet. And now the tagging will happen for this guy, VLAN number 1. Because now I changed the native VLAN is what? Now the native VLAN is 10. So if I'm going to make the native VLAN is 10, so there will be no tagging for the 10. There will be tagging for the VLAN number 1. Okay. How you can change? It's very simple command, man. So make sure that the native VLAN you have changed on the both the device. So you simply go on the trunk interface and say that switch port trunk native VLAN. And I can say that, hey, which VLAN you're gonna make it? I have a range, right? I can define any VLAN number as a native VLAN. I can send the VLAN number 10. And same thing on this guy. So previously it was 1, now it's become the 10.
Okay, sir.
So that's how you can make a trunk, guys. Okay, I haven't done, we have a few more things in the trunk now. We'll discuss tomorrow. If you have any questions, you can feel free to shoot me. Okay, this was the lab. So now the task, what you can do that now. So the task is what? You can do the same lab on your Cisco Packet Tracer. Okay. And please do this lab as well in your EVNG. If you're not going to do that, then you will not understand the coming classes. Okay. Any questions? Does anybody have any questions?
No, sir, still no. Sir, I have one question, sir. Regarding trunk and VLAN, sir. Can I ask, sir?
कौन सा VLAN?
No. Normally, sir, can I ask one question regarding
Yeah,
trunk
go ahead.
and VLAN, sir?
Go ahead.
Suppose, sir, yes, sir. This scenario, show me, sir. Yes. Suppose, sir, I have two switch, sir. Switch 1 and switch 2, sir. Yes, sir. This scenario, what, sir? Switch 1 and switch 2. Suppose we have created, sir, two VLAN for two department. One is for IT and one is for sales, sir. When we configure the trunk, in case, sir, we can configure the trunk, but unfortunately VLAN does not pass all information pass from switch 1 to switch 2, sir. Then at that scenario, what problem we can face, sir?
What did you say? You are saying that traffic is passing, but VLAN is not passing. You're saying that?
Yes, sir. Suppose, sir, in a rack, two switch, sir, I have configured, sir, I have created two VLAN for two department, both switch, sir, switch 1 and switch 2, sir. But when we communicate, when we want to communicate switch 1 to switch 2, we can configure, sir, trunk. But my question is, sir, suppose I can give the command trunk. Then, sir, switch 1 does not communicate with switch 2. At that scenario, what problem? Is there any command missing? Other
Yeah, so
problem?
there will be many problem, right? So maybe check with that your interface is up or not. Okay, make sure that your interface is up. So make sure that you have a proper encapsulation, you have configured it. Like it's not like that one side you have configured the 80.1 key protocol and one side is the ISL. So make sure that both sides
Okay.
have the same protocol, right? Another thing is what? Make sure that there should be a not any kind of VACL configure the VLAN access list. Make sure that this interface allowing that particular VLAN. For example, your VLAN number 10, maybe it's not allowed. Maybe you have filtered the VLAN number 10 on the trunk port. So you have to check for that one as well. Maybe you have to check that on the access port that you are on the receiving the traffic, you may have a port security is configured properly or not. Maybe this access port is working fine or not. Maybe check that if the IP addresses are part of the same subnet or not. So there's lots of things that you have to check.
Okay. So when, sir, switching part is covered, then, sir, I can understand, sir. Couple of things, sir, available, sir.
Yeah.
Okay.
Guys, anybody has any questions for the today?
No, sir.
No. Great.
No, sir.
So
Good night, sir.
everything is
No,
good
sir,
now.
no,
So
no.
what you can do that I'll catch you tomorrow, guys. Okay, and tomorrow we'll do that lots of deep dive in the trunking as well.
Sir. One question, sir. Yesterday, note please upload in the Google Drive, sir.
Which note? The paid file you're talking?
Yes. No, not paid.
Notepad, which notepad is it? This one, Behavior Season Text. This one,
Yes, this one, sir.
I'll upload it.
Okay, good night, sir.
Right.
Thank you.
Thank you, Law. Hey, thanks, Bhujan.
Thank you. Good night.
Hey, good night, buddy.
Good night, sir.
Hey, good night. Thank you. See you tomorrow. Bye bye.